Good evening. Let's recap sequences from our lesson 5.3. Sequences are a list of numbers in a specific order. We call it a pattern. The terms. Each number or element, we call them, in the sequence. Each number in the sequence is called a term. So these are a couple of vocabulary words that we came across in the lesson 5.3. And we also saw sequences can be expressed as functions. Sequences can be expressed as functions. So we know for functions we need two things. One is input, the other one is an output. So when we look at sequences, we have two things that are associated with the sequences, which we can use as an input and an output. So for example, let's take a look at this sequence: 6, 12, 18, 24, and so on. So this sequence is a list of numbers in a specific order or a pattern. So the pattern that we are seeing here is every time it's adding a 6. So the sequence is infinite, meaning it goes on forever until I tell you to stop at a particular number in the sequence. We'll keep on writing that sequence. So the two things that we talked about that are associated with my sequence, the first thing is my position number. Position number of each element. Okay, each element or term. Position number of each element or term, we call it the term number. Call it the term number. The second thing is the actual number in the sequence. Actual number in the sequence, which are these numbers, the 6, 12, 18, 24. It's called the term value. The term number is the position of each number in the sequence. Say 6 in the first position, 12 is in the second position, 18 is in the third position, 24 is in the fourth position, and goes on and on. So it's where the number is in that long line of numbers. Okay, so the position number is first, second, third, fourth. It goes on and on up to nth position. I say n because I don't know where to stop. So if you tell me there are 10 numbers in the sequence, then the last position will be the 10th position. If you tell me there are 15 numbers in the sequence, the last position will be the 15th position in the sequence. So you have the position number and my actual number in the sequence, the term value, which are 6, 12, 18, 24, so on and so forth. I don't know what number goes here until I know what is my n. So as we said, for our functions we need two things. One is our input and one is our output. So we have two things here. One is the position number and the other one is the actual number in the sequence. So we have our term number So we have our term number, we have our term value. All right. So if I construct a table just like I construct for a function, my input output table, this is my term position. It is represented by the letter n. Represented by the letter n. And this is my term value, which is a function of my position number. Term value is a function of my position number. Alright, so I represent it as f of n. So my term position is either 1, 2, 3, 4, goes on and on up to n. And my term value is the actual sequence, 6, 12, 18, 24, goes on and on. I don't know what n is, so I say if I knew it, it will be a function of n. So as we said, this is a function of your position. So this number 6 is my first term value. This is my second term value. This is my third term value. This is my fourth term value. It goes on and on up to my nth term value. So these are my term values. They are my term values. So you have a function which is also a sequence. So sequence can be represented as functions.